So today we start a ray optics and optical instrument. Okay, so the optics group, and these group carry 15 marks approx. Okay, 1 and 2 marks up and down, but each and every year you get almost approx 15 marks, and this group is very easy. Okay, so do not skip that group, and some derivation and basic some numerical. Okay, so try to be too much practice here and you get full marks here. Okay, so do not skip that group, and very easy portion. So that's why today we start a ray optics and optical instrument. Okay. So here first we discuss reflection of light by spherical mirror. Reflection of light by spherical mirror. Spherical mirror. Okay. So what is reflection? Okay, so you know that there is a plane mirror. Okay, and these are the rough surface, upper part is the shiny surface, and some incident ray from source and light travel from source to this towards the plane, and this plane or this line is called line of incidence. Line of incidence. These are the incident ray, and this point is called point of incidence, and draw is perpendicular from that point to the line of incidence. So that's why this line is called normal, and this normal and line of incidence make an angle 90 degree. Okay, so after striking the incident ray back to the same medium, and these are called reflected ray. Reflected ray, and that is a incident ray. This IR stands for incident ray, and this angle incident ray and normal makes angle I, incidence angle, and normal and reflected ray make angle R. This is called reflected angle, and laws of reflection says that is I that is equal to R. Okay, and this is called point of incidence. Point of incidence. Okay, but here this mirror is not a spherical mirror, this is a plane mirror. Okay, this is a straight line, this is a plane mirror, and this phenomena is a reflection, known as reflection phenomena. So now there are two types of spherical mirror. Okay, so spherical mirror are two types. So spherical mirror are two types: concave and convex. Okay, and now concave mirror and convex mirror. So concave mirror is look like this. These are the rough surface here, and the polished and shiny surface left side, and that is a principal axis. Okay, and when a source here and light travel from source towards that a concave mirror, this ray is called incident ray, and that point is called point of incidence. And now I draw a tangent here. These tangent represent line of incidence. Clear? Now draw a normal. Suppose these are the normal. Okay, and normal and principal axis cut that point, cut here, and this point is called center of curvature. Keep in mind, this point is called center of curvature. So after striking this ray back here, and this ray is called reflected ray. This ray is called reflected ray, and that is incident ray. So that's why this angle called incidence angle. This angle is R, reflected angle, and that's a reflected angle and principal axis cut that point is called focus. This point is called focus, and this point is called pole. There is a center of curvature, focus, pole, and you see that these are reflected ray at converge a point. Okay, the reflected ray converge towards the point. Okay, converge. All reflected ray converge and meet a point. Okay, so that's why these called converging mirror, because all reflected ray converge and meet a single point. Okay, and this point is called focus. This is called converging mirror or concave mirror. Similar like a convex mirror, but the shape slightly changed. These are the convex mirror. Similar, that's the principal axis, and the source, incident ray fall that point. This point is called point of incidence. Draw tangent here. Okay, and now draw a normal, and the normal is look like this. This look like a normal, and this angle is I, and after striking this reflected ray goes this direction. This is a reflected ray, that's the incident ray, that's the angle R, and back to this and meet a point. Okay, meet a point, and this point is called focus. Normal cut the principal axis called center of curvature. Center of curvature, and this length from pole to focus. From pole to focus is called focal length, and pole to center of curvature is called radius of curvature. ROC, radius of curvature. Similar like this. Center of curvature to pole, is called radius of curvature. Focus to pole is called focal length. Okay, and here you see that reflected ray are diverge. Okay, reflected ray are diverge, so do not meet a point. Okay, they are diverge, so that's why this convex mirror also called diverging mirror. Diverging mirror. Diverging mirror, and concave mirror is called converging mirror. Okay. Okay. Now another important concept is called sign convention. That's very important. From solving a numerical, sign convention is very important. So sign convention in spherical mirror. And these are the Cartesian sign convention. So we know that these the minus x, these the plus x, that's the plus y, these are the minus y. Okay, and now at that point, okay, at the origin point we place suppose a concave mirror. Okay, so place a concave mirror. Concave mirror at origin. So pole and origin are same point. Okay, and the object place here. Suppose the object place here. Here you place an object. Okay, and you see that from object to source, this incident ray. Okay, and from object to pole, this length is called object distance. From object to pole, distance is called object distance. Object distance. Okay, these are the called object distance, and that is a represent u. These are the u object distance. So after striking, and see that after striking that this ray, incidence ray, back to reflected in same medium. Yes. Okay. and this point is called focus. This point is called focus, F. Okay, and this length, focus to pole, this length is called focal length. These are called focal length. Similar like this, F represents focal length. So these focus to pole is called focal length. Represent small f, focal length. And now after striking, suppose we say that suppose striking another point, suppose goes in that direction, then back to this. Okay, so meet a point here. Okay, and if these are this blue color line also incidence ray, and after start falling on pole and back to same medium, so this angle I, this angle be the R, because these two angles be the same from drawing an image. So here we see that there is the image height. Okay, if I say that is AB, here we get B dash A dash. So actually confused, going short, so we draw a new diagram here. Okay, and these, suppose some object placed here. Okay, object, and someone say that is a incident ray, and this passes to the focus. Reflected ray passes, incident ray after striking, there is a reflected ray passes to focus F, and we need another point, so that's why this passes fall on pole. Fall on pole, suppose this is a pole, and back to this, not look like a pole, this. Okay, these are the point pole, and you see that very carefully, there's a A, that's a B, there's an object, these are the object, and this distance is called U. This is U, and this distance from that distance is F, focal length, and you see that there's this cutting point. Okay, two after reflection, two reflection ray from object meet here, and that's why these are called an image here, image created here, that is A dash, and when a ray from parallel to that is pole or overlapping to the pole, back to same. So here that's the image, that point is called B dash. Okay, and now the image is inverted here. Okay, and you see that from image to pole is called image distance V. Image to pole is called image distance, that is V. Okay, and you see that very carefully, all reflected ray meet a point. Okay, so that's why this image is real image. This image is real image because they meet a point. All reflected ray meet a point. So that's why this image is called real image. Again I say that all reflected ray meet a single point, and that's why that point, for create an image on that point, is called real image. Okay, and now the sign convention. Main important topic is sign convention, and you see that some graphically, and that is that plus x, that is a minus x, plus y, minus y. So object height. So object height is plus y, and image height is minus, because the minus direction image height, object height this direction. Okay, and now another important, object distance and image distance. So object distance always negative. So from origin, there is a origin 0 0, origin point here, these are the origin point. Okay, so there is 0 0. So object distance u, that is minus, and I see that image distance of b also minus left side, and focal length f here also minus, because there is a left side. So there, okay, that's a sign convention, very important, keep in mind. Okay, so that's a Cartesian system, and you see the object and image, where the object and where the image is placed, and that place, keep in mind, now they choose where the object placed. Okay, if that object placed in left side or front of lens, obviously there is a front of lens, left side means the front of lens, that's the object is a minus, object distance is minus, object height towards positive y, so that means object height is a plus, and image is vertically opposite. Okay, so opposite direction, obviously there is the opposite direction or inverted, so that's why the image height be the minus here, and that image also create a front of lens, that's the image also be the minus, focal length also focus point, focus also in case of concave mirror, the focus always left side, so in front of lens, so that front of mirror, sorry, in front of mirror, there's not lens, sorry, in the front of mirror, so focal length also be the minus here. Okay, so keep in mind where the point is there, and the imagine the what is the Cartesian coordinate and what is the plus and minus belongs, then we put the data here. Okay, now there's a concave lens, now we can design for convex lens. Suppose these are the convex lens, and see that is the principal axis, and here the object, and that's the incident ray from object, and that distance is u from point pole. Okay, after striking, say back to the same medium and in that direction. Okay, and see that, and now choose another point here, fall on pole, back to there, and here, and you see that very carefully. If I draw a normal here, okay, and that is that angle be the I, that angle be the R, that is I, that is R, and you see that this point, okay, image create here. Okay, and you see that all reflected ray actually do not meet here, but in backward or virtually they meet here. Okay, so all reflected ray, these are the reflected ray, these are the reflected ray, they are back, so do not meet, but virtually when I dotted line backwards, they meet at here. So that's why this image is called virtual image. Virtual image created by convex mirror. Okay, and that is this distance from pole to this, that is v, image distance, and you see that focus, this is the f, and that is the focal length. So you see that you see that that is a minus x, that is a plus x, plus y, minus y. So u be the minus, object be the minus, image v be the plus, focal length plus, both are in, if there is an origin point here 0 0, the v and f are toward the right side, so that's why there is a positive x direction. So object height plus image height, obviously plus. Okay, they are not inverted, the same, they are erected. Okay, and their size bit small. Okay, the image height be the small compared than object. So that's why these images virtual image, they actually virtually meet that point. Okay, but reality there is a do not meet a point. Okay, there is a virtually meet a point, that's why this image is called virtual image. Clear the sign convention? Okay, that is for convex mirror. Now Find the focal length and spherical mirror. Okay, the focal length here, there is a focal length, and this point is the center of curvature because a normal. So this is the R, radius of curvature. Okay, from center of curvature to pole is called radius of curvature. Okay, now we establish a relation between focal length and radius of curvature. That's very important. Now establish relation between focal length and radius of curvature. Suppose we choose a concave mirror. Okay, that's the principal axis. Suppose there is a object here. Here is the object, and this is the incident ray. Follow that point and draw a normal here. Suppose a normal. First we draw a tangent, then draw a normal. Okay, these are the normal. Keep in mind, these are the normal. So these are the reflected ray meet, that is the focus. Normal meet to principal axis is called center of curvature, and this length center of curvature to pole is called radius of curvature. This length is called radius of curvature. Okay, now I draw a perpendicular from that point. Suppose this point is called point A. Draw a perpendicular from point A to principal axis, and suppose this point is called D, and we ignore this length because DP is very small than focal length. So that's why we ignore DP. D and P are point with the same point. Okay, so now this length is a focal length. From F to D or F to P, both are same. So FD almost equal to FP here. And from the relation, first this normal and incident ray make angle I, incidence angle, and normal and reflected ray make angle, that is R. And you see that this line and this line be parallel, that is a sector. AC is a sector. So this angle be the I because these two are alternate angle. Similar like that, I plus R, and here this line and this line the parallel. AF is the sector. So that's why this angle and this angle be the same. So this angle be the I plus R. And now see the very carefully. I equal to R, there's a laws of reflection, say theta, and now tan and see the first triangle, ACD triangle ACD, tan I means tan theta, that is equal to perpendicular AD by CD. CD say that is R. Now another triangle AFD. So now this angle will be I plus R. So theta plus theta is a 2 theta. So tan 2 theta, that is equal to AD by this length be the F. And for trigonometrically say that, and from geometrically, tan theta is almost equal to proportional to theta, and 2 theta, tan 2 theta almost equal to 2 theta. So we get 2 theta equal to AD by F, and 2 theta equal to AD by R, that is AD by F. AD be the cancel, so we get F equal to R by 2. That's the final expression. That's the relation between focal length and radius of curvature. So radius of curvature equal to twice of focal length. So this length is the F. This length also be the F. and if I say these are focal length f, I say twice of focal length, these are 2f. Okay, so we derive the relation between focal length and our radius of curvature with help of concave mirror. Similar, we prove that convex mirror also. So convex mirror, there's the principal axis, here pole, incident ray from source, draw a normal, draw a first tangent here, that is the point of incidence, draw normal. These are the black color line represent normal, that is C, center of curvature. After strike the back, okay, and the meet here is called focus. Okay, that is a pole. So pole to focus. Okay, these are focal length, and pole to center of curvature is called R, radius of curvature. Now say this point be the A, and draw a perpendicular from A on principal axis, this angle 90 degree, and say this point is D, and we ignore the PD, okay, because PD is a very small. PD is very small on respect to F. Okay, so similar condition here. So now triangle ADF, and we get similar like first we put I, that is R, and this angle with the I. So this line parallel, so this angle with the I, this line be parallel, and this I plus R, this angle also say that I plus R from laws of reflection, I equal to R equal to theta. Say suppose tan theta means this AD by DC, AD by DC means R, and tan twice theta, that is almost equal to theta, that is equal to 2 theta means this AD by DF, that is AD by F, proportional to 2 theta, that is proportional to twice theta, tan 2 theta. Okay, so now similar condition. So here we see that AD by F, that is equal to 2 theta, 2 theta equal to AD by R, AD with a cancel. So F equal to R by 2, or you can say that R equal to twice F. F stands for focal length, R stands for radius of curvature. Okay, these relation actually the focal length and ROC, the focal length equal to ROC, radius of curvature by 2, that is valid for both concave and convex mirror. They both valid for concave and convex mirror. Okay, derive the mirror equation, very important. Now we derive mirror equation. So from derivation of mirror equation, that's very important for board exam. That's very important for board exam. Okay, this derivation, board exam. Okay, so that's very easy. So we choose a concave mirror, and here the object is here, and this object A, and that is a B, that is a incident ray after strike, this is a reflected ray, that's a focus, this point with a focus, and we choose this a point with a pole, and we need another point, midpoint here. Let's say this fall on there, and Okay, and you see that this top point A incident ray starting from this from point A and meet here. Okay, meet here. So that point is called A dash, and here similar strike and back. So now here create image, that is a B dash, A dash, B dash. Let's create image here. Now similar condition here, draw a perpendicular from, suppose say that is M, and these are called M, and these called also say that M dash. M and M dash, this called aperture. So choose that point, and this point also say that P. This point and this point we say P because we ignore this length. Okay, so that's why this point also say that point P. Now we see the diagram. Okay, these are the concave mirror, and there's an image, that's the object. Okay, and now see the two triangle here, the triangle A dash B dash A, this triangle A dash B dash A, and which is another triangle, the triangle is MAP, MAP, this triangle MAP, and you see that A dash B dash A, okay, and this angle and this angle is vertically opposite be the same, and A dash B dash and MP are the parallel, and A dash M is a sector, so this angle be the equal because they two are alternate angle. So that's why these two triangles are congruent. If these two triangles are congruent, the ratio of the similar side be the same. The ratio of the similar side is A dash B dash by height of this MP, that is equal to B dash A similar side ratio, that is FP, and you see that MP that is equal to AB because these two lengths are same, because these two lines are parallel line. Okay, so now A dash B dash, now MP convert to AB, replaced by AB, and that is B dash A by FP. That's the equation number 1. Now we choose another triangle. So now we choose a triangle ABP and A dash B dash P. So A dash B dash P and triangle ABP. A dash B dash P, this triangle, and choose this triangle. Okay, so you see that these two angles be the same because the pole, that is IR, and this angle be 90 degrees, this angle also be the 90 degrees. So these two triangles are again congruent. If these two angles again congruent, the ratio of the similar sides be the same. So similar case here, A dash B dash by AB, that is also equal to this length B dash P by BP. That's the equation number 2. And you see that equation 1 and equation 2 be the same. So here 1 equal to 2, and we get B dash A by FP, that is equal to B dash P by BP. So B dash A means this length. And you see that from object to this distance, from object to pole, that is U, and that is image to pole, that is V, and from focus to pole, that is F, and we need this length, so that's why from we minus this length B dash P minus FP, that is the BF. So B dash P means V and FP means F, so V minus F by FP. So here FP means F. that is equal to B dash P. B dash P is called V, and BP, that is U. That is V by U. Now cross multiply. So VU minus UF, and that is VF divided by UVF both sides. VU UVF minus UF UVF VF UVF, and now UV with the cancel, UF with the cancel, that is equal to obviously VF cancel, that is VF cancel. So we get final expression is 1 by F minus 1 by V 1 by U. 1 by F equal to 1 by U plus 1 by V. That's the final expression. And this expression is very, very important. That is called mirror equation. Okay, this is called mirror equation. Clear? And you see that another term is called magnification. So here another term is called magnification. Magnification. So what is magnification? First you copy the diagram. Okay, from magnification, for understanding of magnification, I see that object in plus y direction. So magnification equal to image height by object height. So object height, that is a plus y direction, and image height is a minus y direction. That's why image height with a minus here, because the image height, that is a plus y, downward is minus y. Okay, that's the magnification. And so image height means minus a dash b dash by ab. So a dash b dash by ab, we see that very carefully, that is equal to b dash p by bp. Okay, from this equation, that is also equal to a dash b dash by ab, that is equal to b dash p by bp. Okay, so b dash p, you see that b dash p, that is v. Okay, so v obviously minus the action, so that's a minus v, and bp is a u, minus u. So we get final expression, that is magnification, that is minus image height by object height, and another formula magnification, that is minus v by minus u. So beta cancel, that is v by u. These are the magnification formula. Okay, clear the concept. What is the magnification? So the magnification we get, that is equal to minus v by u, and also get h dash, say the image height, h dash, that is image height, and h, say that object height, say that h. Okay, because one height with a minus direction. Okay, that's a magnification formula, and these equation valid for both convex and concave mirror are also real and virtual image. Both are satisfied. It is valid for both convex and concave mirror and real and virtual image. Both valid here. So now for a better understanding, we take an example here. Suppose we choose a convex mirror here, that's the principal axis, and if I place object here, there is an object, and you see that that is a incident ray. After striking here, we get a focus, and we need another point for is pole and these two ray meet here. So create image here. Create image here. And you see that these point, so they actually do not meet a point here. So that these two reflected ray actually they produce to backward, when they produce to backward and draw imaginary line for backward and meet a point here. That's why this image is called virtual image. Virtual image. And you see that is for magnification property, that is image height by object height, both be same, so that's a both plus. And you see that object distance, that is a u, and image is v. So we get now the magnification another formula, that is v by u. So here v be the plus, u be the minus. Okay, and you see that both same, v by u, that is a minus sign here. This is valid for here. This is a magnification, and these are virtual image. Suppose we draw another virtual image made by a convex mirror. These are the convex mirror, and these are the principal axis. Here, that's the principal axis. Here we place a object at very far at a infinite place object here. That's the incident ray. After striking, they actually meet goes there, but dotted line here. Now we draw another point line here. Okay, and they virtually meet here, and there create an image. Here is the object, here is the image. Okay, and that is a v, that's the u, that's the object height, that is image height. So magnification, image height by object height, and magnification another formula is v by u, v plus and u minus. So these are also create a virtual image, and both are satisfied. Magnification formula, also the mirror equation. Okay, so I take too much time for, so that's why I end the class here. If you have any doubt, please ask in comment section. I will try to give the answer. So today end the class here. Thank you.